Hey folks, so this is Sanjeev here, and I am taking a moment to create this video so I can put everyone in the FTC class on the same page. Essentially, I know I covered a bunch of this in the orientation, but since I got asked, I thought I would create a little reminder, a video, a point of record that tells everyone what the curriculum is, when we are supposed to hit that, and how the overall plan actually unfolds. So with that, let me switch over to my other machine where I can actually showcase this somewhat better. Okay, so here's the curriculum. Essentially, the way we have been going under the plans of teaching FTC, it's going to be essentially 4 parts. This is the journey to FTC. For this class, and the 4 parts of this thing is essentially FTC. All it requires is Java and mechanical building with the metal parts. However, doing this thing, the Java library is actually created by Qualcomm. So Java, this is Qualcomm library, and this essentially hides everything, including and it hides programming. Like most of it, you can just ignore it and insert a few lines and be done. It even hides things like I would say the underlying electronics, and so on and so forth. So doing it in this particular way over here, it's not super useful. Essentially what it does is it gives kids a false sense of accomplishment, especially since the kids that are actually doing this are grade 7, 8, and up to high school, actually all the way to grade 12. So they feel like they actually know how to do something when they don't really. I mean, as in you give them tooling, industrial level tooling, and they fall apart. So the goal was essentially the goal for me always was, let me get out of this thing and go to the drop section and pick up a red pen. And so the goal was always to come to this portion towards the end, tell the kids how this works towards the end, and in the meanwhile actually teach them something worthwhile, which is actually applicable to both FTC and FRC if and when the kids actually want to get to it. So essentially the first thing that I wanted to teach was C programming over here. Okay, and in C programming, again, C is a relatively straightforward programming language with a small subset of features. But over here, there are a few things that you actually need to learn. The first one is small concepts like variables, basic expressions, right? Idiosyncratic syntax, debugging, and so on. So essentially, this is the very basics of the programming language, including an exposure to the industrial tool Visual Studio, saying this is how you actually use it. This is a real life skill that is useful for them going forward, as in as soon as they start looking for internship, this becomes immediately useful. So that part is there. The second part is flow control, and this is essentially conditional statements such as if else statements. Then there are loops for and while loops, and then if we feel like it, a switch statement, although for most per practical purposes, if else is plenty enough for kids, so I just ignore the switch. That being said, if a kid is interested, I would definitely recommend them picking this switch statement as well. Then the third piece is essentially functions. This is a key thing that we need to go forward to explain what is modular design and how do you actually program in a modular fashion. So we go over functions, function signatures, how to program, package up code. Along with functions comes the concept of scope. Local scope comes in, and then I guess reusable code. Right. So this all of this actually comes in, and then the next thing, essentially there are two more concepts that we need to understand. One is arrays, And along with this, we introduce the concept of strings in C as character arrays. And then finally we have, if time permits, we go over structures. And that's pretty much we stop here. You observe that I am kind of, pointers is one more leg of C, but I have had experience where many kids actually have a hard time understanding and working with pointers. So it's not really necessary. We just ignore this thing and work with code without pointers. So those are the things that we are planning to cover, and we are not going to cover file handling or writing your own library. So all of these are actually we are just going to ignore. So this is the small subset that we need for getting to the next leg of our journey. So this is part number 1, and then this is part number 2, and this is part 3 and 4 together. These will actually, we will go through them together because it makes sense. The programming for the Java portion actually kind of makes sense along with the getting to the mechanical components. But before we get there, we need to understand some of the details. So now let me expand on part 2. So part 1 is pretty straightforward, like C programming with the bare minimum core set that is required for kids to become somewhat proficient at programming and understand what they're doing. Now let's look at the second part. So part 2 is essentially Arduino programming and prototyping. Okay, so this one actually requires access to an Arduino, and we'll provide this in the class, and it will require programming with C. So that's why the first module is programming with C, so kids can understand that. While programming with C, we also ensure that kids get access to electronics, so that they are not feeling like they are on this dry journey. Every once in a while we switch over to electronics and get them some explanation and understanding of electronics. So Arduino programming with C and real life hardware prototyping. So we are expecting that module 1 over here, the C programming, this should be covered by somewhere, I would say mid-April. Okay, we will see. If we are not covered, then we will actually, whatever knowledge we have, we will dive into the Arduino no matter what, somewhere around mid-April. And then the Arduino portion will last April, May, I would say probably April and May, maybe June mid. Okay, and then part 3 is the Java plus the FTC robots, and this will actually go fairly fast. The kids will understand. Essentially, they don't really need to understand too much in Java and robots, and most of the work actually is building a robot. That's the way it goes in FTC. Like 90% of the time is actually spent building the robot, and as far as the programming is concerned, it's very little amount of programming. So we will start this somewhere in June mid / July, and we will probably continue this one till August, September, when the competition actually starts, and then we will actually pick that on. Understand this, that over here, C programming language, the kids will get familiar with it, and they will be I would say 40 to 50%, maybe 60% proficient with the programming language. Unfortunately, since the time is limited and we have to move on, we will have to move on from there on to the Arduino based programming. And over here we will spend again another, I would say they will become about, I would say 20 something like 30% proficiency with Arduino, the amount of proficiency that I want, that we at InnerSpark actually want. And then finally this one, they will become reasonably familiar, I would say 50% to 60%, at least with the build portion of it, and the programming portion of it, that will take them a while. But the actual programming required for FTC is fairly little, because a lot of it is actually prepackaged in form of libraries from Qualcomm, so you actually write very little code over here. So that's kind of the goal. Mid-July will start, and this will continue on till, I would say, September first weekend. around when the FTC is actually announced, and then we'll take the FTC challenge and go on with it. So that, I hope, gives you an idea. I'm gonna draw this on a timeline. So if this is the timeline, we started in February, I would say around February 1, and then till, like, this is April 15th or so. This is C programming, right? C programming. This goes all the way till here, and April 15 till, I would say, June or so, like, June slash July 15. This will be Arduino. Okay, and then finally we will hit all the way till from here all the way to September 1. This will be FTC plus Android / Java. Okay, and from this point onwards it will be FTC prep. And as I said, the goal is here, like, throughout this year we build competency. So that when the kids go over there, they are fairly competent. I'm not sure how much of how competitive they can really be, since this is also our first year. We will have to see how competent the kids really get. That being said, I mean, I have looked at it quite often, and I have worked with those robots, and they don't seem significantly different, apart from the fact that it takes a lot longer to build that robot. Programming is fairly straightforward. So I think we will be fairly competent. Once we repeat the same thing the next year, the kids should become really familiar with the C, Arduino, and Java, all of it, like, very well, and they will become super competitive by the end of the next year, including all aspects. So anyway, so that's kind of the overall view, and thank you for watching. And if there are any questions, please feel free to email or talk to us at the end of the class. Thank you.